Good afternoon and welcome to our Career Day presentation. We're pleased that you could join us for this virtual career fair today. The topic that I'd like to talk to you about is the career of software engineering and computer programming. And there's a bit of a difference between the two, although they're very closely related. Computer programming is the writing or maintaining of the code that gives the computer specific instructions on how to perform specific tasks. A lot of the time that we think about computer programming, we're thinking about creation of new programs. We live in the age and the world of applications. Many of you have downloaded applications to your smartphone or to your tablet or to your computer over time. And you've had some experience with applications. A few of you have probably even programmed or created applications. But it's important to note that a lot of the development work and a lot of the programming that goes in to computer applications only accounts for a fraction or a portion of the total amount of programming that takes place in the world. We also have these large bases of existing programs that have to be maintained. And so maintenance programming is an important part of this world as well. Software engineering, on the other hand, is performing all the aspects of analyzing, planning, doing the logical design, which is implementation free. We don't get into the specifics, but we want to get the concept right first in logical design. And then we move on to physical design, which is where we deal with the nuts and bolts and the specifics of what it is that's going to be in the system. So once you get the logical design, you move to physical design, and then you test. You may implement the system then, and then you perform those ongoing maintenance tasks and support tasks for that system. And usually this involves using tools and platforms. The key thing about software engineering is we're actually applying engineering principles to the development process. So software engineers do more than just programming. The future is very bright for both programmers and software engineers. We have a greater dependence in our world on systems. You know, we have air traffic control systems. We have medical record systems. We have all kinds of systems around us that run our power grids and our infrastructure. And we have systems that run our organizations. So all of these things add up to a lot of demand for software engineers and programmers. The systems that we do have are becoming more complex. What used to be simple systems now have more features and more capabilities, and they have to interact with other systems as well. And that makes them more complex, and therefore we need a more formalized approach to dealing with them. Gone are the days when the programmer could sit down and write the entire piece of software all by themselves. Now it takes teams of programmers to develop many of these sophisticated systems and applications. Embedded technologies are becoming more commonplace. The Internet of Things promises to put billions of new devices connected to the Internet over the next decade. And most of those devices are not going to be smartphones, they're not going to be computers. They're going to be devices that have sensors and create data and capture data and report data and help us interconnect all of our world together, and all of the appliances and vehicles and all of the various parts of our world will become interconnected. And we also have new developments like virtual reality and augmented reality and mixed reality. And somebody's got to develop the applications for those. And that's just one of many examples we could give you of new technologies that will require software engineering and programming. There's also a wave of information technology professionals who got into the field early on, and a lot of those folks are hitting retirement age now. And because they're hitting retirement age, companies are hard-pressed to find enough replacements to fulfill or fill those positions of the retirees, plus continue to add enough capacity to continue to build to the demand for new applications as well. So they've got to fill both new positions and provide replacements for existing positions. So we've provided you with a couple of links here. There's an excellent link there for the Bureau of Labor Statistics. It's specifically designed to have items of interest to K-12 school system students. Growth in the field is forecasted for both software engineering and programming, and you can look at the other information technology related fields while you're there as well. And we've provided this second link that's the Bureau of Labor Statistics Occupational Outlook Handbook. And it will tell you the growth rates forecasted for each of the computer occupations. It will tell you the median salary for a certain time period. It will tell you what people in that profession typically do. And it gives you some examples of careers in that field and what the pay ranges might be and things like that. The duties that people in this field often perform is to analyze what a computer system needs to accomplish by communicating with both management of the organization or whoever is requesting the project, and with the end users, the people who are actually going to use what gets built. We also analyze and outline the business practices that have to be used in conjunction with a computer system. So who is authorized to use this system? For what purposes are they authorized to use it? How often do we run reports? Who controls the data input? Who controls what data we output from this as well? How long do we retain records? How long do we store things in our databases? All of those types of things play into the business practices. Do we capture the information from others on paper and then somebody keys it into the computer? Or do those end users of the system actually enter their data into the system directly without any paper being involved? They also research software and hardware systems to accomplish needs. Okay? There are a lot of systems that we build from scratch. We program them from the ground up, we design them from the ground up. But in today's fast-paced world, we also solve a lot of system needs by taking components or parts or functionality that's available and hooking it together in unique ways to solve the problem. So we might take off-the-shelf software that's already been created, and we might take hardware, computer hardware, the equipment, and put those together in some type of unique way, maybe with some programming that we do ourselves, or maybe some programming that's already in existence is used and no additional programming is needed. But we often integrate solutions by choosing software or choosing hardware that already exists in some circumstances. So if we're creating new software or hardware or there's some programming involved, we have to figure out how we're going to implement that, how we're going to roll that out to the organization. And that involves training, it involves testing, it involves getting the financial support to acquire it in the first place and then to keep it running once it's been installed. So a lot goes into that. Other duties are, actually writing the code and debugging it. There are some students, some people who are cut out to be programmers, and they are coders at heart. They build the programs one line of code at a time, or they use object-oriented approaches which allow them to take code from repositories or code libraries and insert that code into what they're working on and then write the things that are needed around that existing code to create a complete application. Then they'll implement and test the computer system, and that's very vital. We rely so heavily on our systems, we need to test them to make sure that they're going to perform as they're designed to perform. And then we monitor the system while it's operating for consistency, and that it's performing as expected, and that we have the functionality there that the end users need to be able to do their jobs. The types of education and training you'll need, well, first thing, get that high school diploma. That's your stepping stone to higher education. In some cases, there are IT careers that you can hold with a high school education, but most of the IT careers require some type of advanced study, maybe a 2-year community college degree, maybe a 4-year college degree. In some cases, maybe an advanced degree, a master's or a doctoral degree program. Sometimes you need special certifications, and a lot of educational programs will allow you to get those certifications as part of completing the educational program. A bachelor's degree in computer science or computer information systems is usually recognized as the entry level qualifications to a career in computer programming or software engineering. That's typically what's needed to get your foot in the door for those careers where you're expected to progress once you're past an entry-level position. A master's degree might be required for some. Again, you might get that in computer science, you might get it in computer information systems, you might get it in a specific program that's highly focused on software engineering or computer engineering. And then you might get specialized training as well. For example, you might get trained in the particular brand of mainframe computer that you're going to program on, or the particular type of database that you're going to have to support. Or you might get trained with a networking certification in the brand of network that you're going to be building and supporting. You might be trained to specialize in a certain programming language or a set of programming tools that are out there. So there's lots to be considered there as well. Typically, the preparation involves both formal education, classroom instruction, but it also typically includes developing skill sets, getting some experience, getting some practice with the type of work that you're going to be doing for a living. Technology is really exciting, really fast-paced. It's a very dynamic field to get into, so very seldom do you hear complaints that I'm bored, this is the same thing day after day, this is getting old pretty fast. You don't hear those types of complaints because there's always new challenges, there's always new technologies. It's like hopping on a treadmill. You have to keep up or you'll eventually fall off the back end of the treadmill. And so there's continuous training, there's a lot of continuing education in this field on new computer systems, languages, software, hardware. You have training to keep up to date as well on current business practices. Things change in the organization that your information serves. So you've got to keep that information system well aligned with that organization and let it have a good fit with that organization. Skills that you might need to be successful in this field? Well, it doesn't hurt to have logical thinking skills. It also takes some planning skills and maybe the ability to look ahead and decide how you're going to get to that solution you want to construct. There's communications that's needed as well, both verbal communication skills and written communication skills. So it's good to hone those. There's some basic mathematics skills involved in software engineering and in programming. And in some cases, if you go into high-end software engineering or certain subsets of testing or computer engineering, then you might need even higher level math skills. Dedication and persistence is a plus. People who are successful in this field often have to exhibit the concept known as grit, the ability to stick to it even when learning something new is tough, or even when something you're trying to build isn't working quite right. You have to persist. You can't give up at the first challenge, okay? So you need to be able to stick with it and persist as you face those challenges. And the more challenges you overcome, the more confident you become, the more well-versed you become in your field, the more expert you become, and that gets you to a point where you can be successful and self-confident and able to face these new challenges. You have to have a flexibility and a willingness to change and learn new things. For example, for a long time we thought that we had to keep all of our files right on our desktop and have a big hard drive, and we had to manage all of that stuff there. Then eventually we had to adjust to storing a lot of our stuff on the server and connecting our computer or device to that server. And now we live in the world of cloud computing. So we store our stuff out there in the cloud, and we use the internet and network access to get to it. Somebody else manages the storage. Somebody else manages those systems. So we've had to adjust and change. There's always new developments. And then it used to be that programmers and software engineers could be kind of that lone wolf superhero that did it all. They created the entire program or the entire piece of software all by themselves. But as our world got more complex, and as software and systems got more complex, and as organizations got more complex, it became much more challenging for one person to embody all of the characteristics that it took to do a project. So now teamwork is valued very highly. And we have new approaches called agile methods and other similar types of ways of addressing problems that value teamwork very, very highly and make it very, very important. Teamwork becomes paramount to success in a lot of organizations doing these types of work. The advantages of going into this field, reasonably high pay. Again, if you go to that occupational outlook handbook from the Bureau of Labor Statistics at the link earlier in the presentation, you'll see just how much that pay is for each of those categories of computing careers. It's also important to note that you have good working conditions. You know, you're typically in a clean environment that's temperature controlled. You don't have a lot of risk as you go through your workday in terms of dangerous working conditions. You know, you're not at extreme heights or extreme depths in the ocean or whatever. So there's something to be said for that in terms of longevity and your health and so forth. And it's a fairly stable field. Even in economic downturns, IT, information technology, is so important to organizations that they tend to only cut spending on IT if they absolutely have to. Otherwise, they'll try not to lose any ground on the progress they made. So it's very stable, but it's a dynamic field. It changes. It's not going to get old. It's not going to get stale. There's always new things to learn and new systems to build. The challenges, well, it's hopping on that treadmill. It requires constant effort to keep your skills current and to advance in your field. So related careers are the computer programmer. You could also work just with the data side of it and be a data administrator or a database administrator. The data administrator deals with the what we're going to collect, and the database administrator deals with the how we're going to store that, process it, retrieve it, all of those types of things. Software engineers fall into this field. They apply engineering principles to the creation of software and software systems. Web designers, a closely related field. Many of the approaches that we use for traditional programming and agile approaches to programming can also be adapted and used for web development. Hardware engineers, the people who build the equipment, that's a closely related field. Somebody's got to create that projection system or that new monitor or that new computer or that new tablet or smartphone or whatever it might be. And then e-commerce specialists, the people that deal with how do we buy and sell and support customers online, and how do we deliver digital services and products like streaming of entertainment and so forth. How do we support video conferencing? Special advice, if you want to go into this field, identify your interests, okay? It used to be that this field was kind of monolithic, it was kind of focused, and it was a very narrow range of activities. Now the world of IT has expanded out so that there are openings and positions for people with a wide variety of interests. Match the interests that you have with the required career skills. And if needed, find ways to enhance and build those required career skills. This is a great time while you're at the age you are. You might think you're busy now, but it gets busier later when you get older. So this is a great time to take a little time and explore and enhance those skills. You know, we have YouTube, we have TED Talks, we have a host of tutorials and practice trainings and so forth that you can access online. Some of your schools might offer specialized programs that let you enhance your skills. Now is a good time to invest in yourself and develop some of those skills. Job shadowing is great. A lot of organizations welcome job shadowing. If you can get an internship or a part-time job, that's great as well. And then talk to someone in the profession. We welcome students who call us up or come visit us and talk to us about, you know, what is it like in this profession. Some things that you can do to get started now, if you're interested, explore some of the introductions to computer programming. A very simple one is Scratch at the MIT EDU link there. If you want something a little more sophisticated, you can build some of your own games and storyboards and so forth with alice.org. Both are free downloads, free to access. By the way, before you install any of this stuff on your school's computers, make sure you get permission. Same way at home, you know, check to make sure that it's okay to download some of this stuff. Some of it is web-based, so there's no download necessary, there's no installation necessary. But other things that we'll mention here, check and make sure you have permission to use them before you utilize them. You can watch videos. There's some specialized ones. The Hour of Code project is a big one, and some of you might have already had some exposure to that, but if not, go to the Hour of Code link there. You can read programming books and do online programming tutorials. The W3 Schools one is a really good one. Another one is code.org/learn, and you can spend a lot of time on sites like that, and then you'd be amazed at how much you learn in a short amount of time. And it's fun learning as well. They make it very fun. And since this is a virtual event and you're not here to pose questions, I encourage you that if you have any questions about this presentation, please feel free to contact me or other faculty members in our department. You can reach us at the phone number listed on the slide there, 402-375-7545. You can also arrange to come for a visit if you'd like and discuss your questions that way as well. And we wish you all the best. Thanks for your interest in computing careers. It's an exciting field, and we hope you give it a good hard look. Thank you.